You hear me? Can you see my screen? So today we continue learn chapter 3, section 3, that's word problems. In the previous sections, we already learned how to solve equations, right? But most of the time, they did not give you that equation just like you to solve that equation. They usually give you a word problem, ask you to set up that equation. Then you solve that equation, then give the answer for that equation. So, but actually the most hardest part is set up equation. This is the most difficult part. Now let's see how we can solve a word problem. This example, that's 3.12. Say here, 3 less than 2. 3 less than 2 times a number equals
there's so many people.
Equals 4 times the number plus 8. Okay? So to solve this equation, this problem, they give you these steps. Totally 1, 2, 3, 4, 5 steps. Okay, the most important part, you need to understand this word and convert this word to the mathematical languages. So see here, 3 less than 2 times a number. We don't know that number, right? They ask we to find that number. So then we can say that's x. Then 2 times that number. So that means 2 times this number. And 3 less than this. So that means this one minus 3. Then this one equals 4 times this number plus 4 times the number plus 8. Okay? So that means this one equals this. So they give you this equals, right? So 3 less than 2 times a number. Suppose that number is x. So that means 2 times x minus 3 will equals 4 times x plus 8. Then let's see these steps. A, choose a variable to represent the number. Then we choose this x to represent this number, right? Then B, write expression for 3 less than 2 times the number. Okay, this number is x. 2 times this number, that's 2x. 3 less than this, so then minus 3. And for 4 times the number plus 8, that means 4 times x plus 8. Then C, write the equation to represent the problem. So they tell us these two numbers are equal. The one number, that's 2x minus 3. Another is 4x plus 8. They tell us this one equals, right? So then by this way, we set up this equation. We get this equation that's 2x minus 3 equals 4x plus 8. Then solve this equation. Solve this one, it's not hard. We already learned first you need make the one side, usually left side, only has a term with variables. The right side only has numbers. That's called isolate the variables. To do that, both sides you minus 4x. You get a negative 2x minus 3 equals 8, right? Both sides minus 4x, then left side will have no variables. Then here, both sides plus 3. You got negative 2x equals 11. Then both sides divided by negative 2. You got x equals negative 11 over 2. Okay, this will be the solution, right? Now you need to check your answer. Before you check, you don't know exactly if you did it right. That means you need to plug this number to your original equation. Check if this number can make the both sides of the equation are equal. So now let's plug this one to the left side of this equation. We got this side will be negative 11 minus 3. That will be negative 14, right? This is left side. Then now let's plug this one to the right side. 4 times negative 11 over 2, that will be negative 22, then plus 8. So this one also gives us negative 14. So now both sides are equals negative 14, so that means they're equal. So that means this one we get that's correct. So this is exactly the steps for you to solve a word problem. First, you need a sign of variable to represent that number. Then you convert the English language to the mathematical language. Then you write an equation. Then you solve the equation. Last step, you check if this answer satisfies this original equation. Okay, so then for each this word problem, you need to follow this steps, 5 steps. Now let's see next example. Here, 3.13. Each sack of apples at the farmer's market has the same number of apples. 7 apples are needed to make one of the mom's excellent apple pies. I use 3 sacks plus 2 extra apples to make 5 excellent apple pies. Okay, see here, they let x be the number of apples in a sack. Use the information in the problem to write the equation. So now let's see. Each sack of the apple at the farmer's market has the same number of the apples. Okay, this is the same. That means if you have 2 sack of the apples, you can times 2 to the number of sacks. Then get the suppose each sack has 10 apples. Then now you have 2 sacks. Then you use 10 times 2, you got 20 apples. So now see here, 7 apples are needed to make one of the mom's excellent apple pies. I use 3 sacks or plus 2. 3 sacks plus 2 extra apples to make 5 excellent apple pies. Okay, now let's set. Let x be the number of apples in a sack. So then what I use the 3 sacks of apple, then plus 2 extra. So that means I used the 3 times x plus 2 apples, right? Then I make the 5 pies. Each pie needs 7 apples. So that means totally I need 5 times 7, right? Because each pie needs 7 apples. So 5 pie we will need 35 apples. Then I use the 3 sacks of apple, add 2 extra. So that means this number 3 times x plus 2 equals 5 times 7, right? So then they ask you how many apples are in each sack. So that means you need to solve this equation. This equation is very easy. First, simplify both sides. You get a 3x plus 2 equals 35. Then isolate variables. So that means we need both sides minus 2, get 3x equals 33. Then both sides divided by 3, we get x equals 11. So that means our answer, that's 11. Then you can check, you plug this 11 to original. Actually, you need to put to the word problem. But first, you can check if you solve this equation right. 3 times 11, 33, then plus 2 equals 35. That's right. Then you can put this number to the original word problem. Read it one more time. See if that makes sense. Say you can start from here. 7 apples are needed to make one of Mama's excellent apple pies. I used 3 sacks or plus 2 extra apples to make 5 excellent apple pies. That's 35. Each sack, that's 11. 3 times 11 plus 2 equals 35. That means what we did, that's right. Okay, so then now let's go to next problem. This one is 3.14. This one say I am now 3 years younger than twice what my age was 6 years ago. What is my age now? Okay, say to solve this problem, we already learned you need to set a variable to the problem, to the number they ask you looking for. Say here they ask you find my age now. Now let's set my age is x now, right? Then you go back, read this problem carefully. I'm now 3 years younger than twice what my age was 6 years ago. So then you need to first convert. My age was 6 years ago. What is my age? That would be x minus 6, right? This is my age 6 years ago. Then twice this age. So that means you need to times 2. So here you need to pay attention. Here you need to add parentheses here. If you just put 2 there, if 2 times x then minus 6, that's wrong. Because the twice, that's for the age of my age 6 years ago. 6 years ago, my age is x minus 6. So you times 2, that's times to both these two numbers. Or you times to the whole of this number, x minus 6. You not only times to x. So that's the reason you need to add a parenthesis here. Then say, after you get this number, say I'm now 3 years younger than this number. So that means you need a minus 3 here. Then I'm now 3 years younger than this number. So that means when this number minus 3, then they will equals my current age, right? So then we can get the equation that's x minus 6 parentheses times 2, then minus 3 will equals x. Now you need to solve this equation. To solve this equation, first, now let's simplify both sides. You know, right side is already only one variable. That's no way we can simplify. But the right side we can distribute. Get 2x minus 12, then minus 3 equals x. Then we can write this one's 2x minus 15. equals x. Then both sides minus x, I got x minus 15 equals 0. Then both sides plus 15, then got x equals 15, right? So that means my current age, that's 15. Then you go back, say, I'm 15. 3 years younger than twice what my age was 6 years ago. So I'm 15 now. 6 years ago, that means I'm 9. 2 times 9, that's 18. 18 minus 5 is also equals 15. So that means what we did here is right. So the answer is 15. That's my current age. Now let's go to next example, 3.15. This one comes from AMC 10. So that means it's American high school math competition for 10th grade. So all the students should be under or attending 10th grade. Now let's see this problem. Al gets the disease algebraic and must take one green and one pink pill each day for 2 weeks. A pink pill costs $1 more than a green pill, and Al's pills cost a total that's $546 for 2 weeks. Then how much does one green pill cost? So here you can set, one green pill cost, that's $G. Okay, let's use this, help us to memorize this for green pill, each one. Then you can get a pink pill. Each pink pill will cost how much? That will be G plus 1. Suppose each green pill costs $G, then each pink pill costs $1 more than a green pill. So that means pink pill costs G plus $1. Then they said Al's pills cost total of $546 for 2 weeks. Each day, he need to take a green pill and a pink pill. So that means each day, let's do a green pill plus a pink pill cost. This put together, that's a cost for each day, right? Then 2 weeks. In 2 weeks, you have 14 days. Each week, you have 7 days. 2 weeks, you have 14 days. Then 14 times this number should give you 546. Okay, so this is the equation. What do we get here, right? So say here, this is each green pill cost. This is each pink pill cost. Every day, L need to take a green pill and a pink pill. The cost, that will be G plus 1. Then this for 14 days, that's 2 weeks. Total cost, that's 546. So then now let's simplify this equation. We can both sides divide by 14 first. Then inside of this parenthesis, we merge this 2G together. We got 2G plus 1 equals, now let's use 14 divided this 1. Now got 3, that will be 42. Then that will be 12, 126. Then what do you need to put here? That will be put 9, right? That will equals 126. So then we continue to solve this equation. Got 2G equals 38, both sides minus 1. Then we got G equals 19. Okay, so that means each green pill cost $19. Okay, this one costs $19. Then that means each pink pill costs $20. Now that means each day L will spend $39 for a green pill and a pink pill. So that's 14 times 39 equals 546. So that means what we did there, that's right. Okay? So that's the general process to solve a word problems. Right? Now we already finished this section. Now let's go to next one. This should be your access homework. Now here, this section actually is very interesting. You know, a lot of times they give you the equation looks really complicated, and also is not a linear equation at all when you first look at it. But after you do a variable substitution, then the problem actually will become a linear equation. So this one we call the linear equations in discourse. Okay, now let's say this example, problem 3.16. In this problem, we solve for x in equation 3 root x minus 2 equals 30 minus root x. See here, this is not linear equation. You know, linear equation, that means the power of x should be 1. The equation related only to x. This one, the power x power that equals 1, we call the linear equation. So then you can say, suppose x plus 3 equals 3x minus 1. Say all of the variable x here, the power is 1. If you don't write that number, default, that's 1. But for in this equation, we can say, you can write this is power that's 1/2. This one, that's 1/2. So that means this equation is not a linear equation. If you don't do anything here, just keep this original form. This is not a linear equation. But if we use another variable, suppose we use y. Let's set y equals root x. Then we plug this y to replace this root x. Then we can get 3 times y minus 2 equals 30 minus y. Now you see the power of y, that's 1. Always variable in this equation, y. Their exponents equals 1. So that means this equation is a linear equation. And also very easy to solve. Then we can solve this equation first. Now let's see what do we get for y. To do this first, we can both sides plus y. We get a 4y minus 2 equals 20. Right? Both sides plus y. So left side, that's 4y minus 2 equals 20. Then both sides plus 2. You get a 4y equals 22. Then both sides, this is a 30. Okay, so that means what I write here is wrong. That's equals both sides plus 2. Then you get the 32. So then both sides divided by 4. Then you get a y equals 8. Right? Get a y equals 8. But then you don't forget, here we don't have In the original problem, actually, we don't have this variable y at all. They did not ask you to find y. They ask you to find x. So that means you need to plug back to your substitution. You get this y equals 8. Then from this equation, you need to find what is x. So then say square root of x equals 8. So that means x equals 64. So this one is very easy, right? Then you can go back check. Root 64, that's equals 8. 3 times 8, that's 24. Minus 2, that's 22. That's left side. Right side, x equals 64 square root, you got 8. 30 minus 8 also equals 22. So that means correct. So that's the process. We try to just do a variable substitution. Then we convert a nonlinear equation to a linear equation. Then we can solve that linear equation very easily. After back, then we plug that number to the substitution equation, then get our original the variable x. Okay, this is a process to do that. So here they show you let y equals root x. Then write the equation, this one in terms of y instead of x. Then you got this equation that will be 3 times y minus 2 equals 30 minus y. Then solve this equation in parts of y. So both sides plus y, you got 3x equals 30. No, here that will be 4y equals 32. Then both sides divided by 4, you get y equals 8. Then last step, use the value of y to find x. Because root x equals y. This one equals 8. Then both sides square, you got x equals 64. So this is an exact step for you to solve a linear equation in discourse. Now let's say another example. So in this problem, we found x if 3 over x minus 2 equals 7 plus 2 over x. We try to solve this equation. So this is not linear equation. Why? Because this one we can write as 3x power negative 1 minus 2 equals 7 plus 2x power negative 1. So this power, they're negative 1. Is there not 1? If this is 1, then this is a linear equation. But this power is not 1, so that means they're not linear equation. But to solve this problem, you can do a variable substitution. You can set y equals 1 over x. By this way, you plug y to replace 1 over x in this equation, then get 3 times y minus 2 equals 7 plus 2 times y. Okay? Then both sides minus 2y. You get a y minus 2 equals 7. So then both sides plus 2. You get a y equals 9. After you get a y equals 9, you plug back to here. You get a 1 over x equals 9. So what is x? So from here, you can get x that equals 1 over 9. Right? When x equals 1 over 9, 1 divided by 1 over 9 will equals 9. So this one will be the answer. Right? So this kind of problem, when you first look, it's not linear equation. It looks hard. But then you can think, what kind of variable substitution I can use to convert this equation to a linear equation. Then after I get a solution of this equation, then I can plug back to my variable substitution equation, then continue solve the variables you're looking for. Okay? So this is 3.17. Now let's see the next one. 3.18. This one we have three equations. Now let's see first one. You know, this one looks hard, right? You have a variable that's z, but a variable z is under the cubic root 3, right? This one looks really hard. But then if you think, let's do a substitution. Let's set x equals 2z plus 1, then root 3. The idea is this. This one's hard, right? Now let's set this one as equals x. Then we can get this one will be x minus 5, then plus 2 times x equals negative 14, right? Then we can solve this. This will be the linear equation, very easy linear equation. X plus 2x, that's 3x. 3x minus 5 equals negative 14. So then both sides plus 5, we got 3x equals negative 9. Then that means x equals negative 3. Okay, x equals negative 3. Now let's plug back. Negative 3. Then from this equation, we need to try to find z, because in this equation, they ask us to find z. They did not ask us to find x. To solve z, we need both sides cubes. Then we can get this one equals 2z plus 1 equals negative 3, then cube. Because this one will be equals negative 27. Then both sides minus 1. Let me write here. Then get a 2z equals negative 28, right? Both sides minus 1. You get a 2z equals negative 28. Then z equals negative 14. Okay, this will be the answer, right? So don't be scared. The equation looks really hard, but then you put that this part as x, then make this equation will be a very simple linear equation. Then solve this linear equation, you get a x equals negative 3. Then you need to go back to plug this negative 3 to the substitution equation to here, because we are looking for z, we are not looking for x. You put this one equals negative 3. Then both sides cubic. Then you get the 2z plus 1 equals negative 27. Then both sides minus 1, you get 2z equals negative 28. Then both sides divided by 2, you get z equals negative 14, right? So this is a approach we solve this problem. Now let's see second one. Second one, you know, this also you have square root of r. This also not a linear equation. But then we can set this one as x. Then now let's see what we get. We set x equals root r. Then this equation will convert to 2x plus 13, then minus x equals 9 minus x, right? Now say you have this negative x, this negative x. You have a same number as both sides. Then you can consider there, you can cancel out. It's like you have a scale, you put the same thing on the both sides. If you remove this from both sides, your equation still satisfies. So then we can remove this negative x from both sides. We get a 2x plus 13 equals 9. So then both sides minus 13. We got 2x equals negative 4. So then we get x equals -2. X equals -2, then we need to plug back x, that's root r equals -2. So then you need to make sure here, if you both sides square, looks like you will get r equals -2 squared equal to 4, right? But you need to think, is root r can equals -2? Is this one possible? Right? If you suppose r is a real number, this one is not possible. It's impossible. So that means from here, when we solve here, we already know this equation has no solution. You can write no solution, no real solution, no solutions, right? Because root any number, root this one should greater or equal 0. But then after we simplify this equation, we get this one equals -2. Then that means you need to stop here. You write no solutions. If you don't notice this, then you still square, then you get r equals 4, right? Then now let's plug back, say if r equals 4 is satisfy this equation. Say if r equals 4, then you get the left side, that will be 2 times root 4, that's 2. So 2 times 2 plus 13, then minus root 4, that's still 2, equals 9 minus -2. Say -2 and -2 cancel out. You see 4 plus 13, that's 17. Is 17 equals 9? No, this one's not possible. So say that means r equals 4 is not the solution of this equation. If you don't pay attention, just square both sides, you got r equals 4. Actually, this one is wrong. R equals 4 is not solution of this equation, right? So when you do this kind of operation like square and square root, this kind of operation, you need to pay attention. Is your check, is that one possible? Say, here you got a root r equals -2. You know, this one is not possible. How? A number square root, you got a negative number. That's wrong. Okay? So that means this equation has no solutions. Now let's go to C. This one is also not a linear equation, right? So then how we can solve this equation? To solve this equation, we need to do some substitution, right? Definitely we need to do some substitution. We can do this way. First, let's write this equation here, x over x minus 1 plus 2 over 3 equals 2 over x minus 1. But actually solve this equation, you have a lot of ways. You can also both sides times 3 times parentheses x minus 1 times this one, because this one is a common denominator. By doing this way, then you can convert this equation to a linear equation, because this denominator will cancel out. Here you have a term will related to x. This one also related to x. Then this equation will be a linear equation. This is one way. Now, if you try to do the substitution, you know, you can write this one as this. Make the denominator, this one it's x minus 1, then plus 1, right? Because numerator, that's x. Then divided by x minus 1. Then still write this one, 2 over 3, then equals 2 over x minus 1. Then this one divided by this one, that's 1. We can write 1 plus 1 over x minus 1. Then plus 2 over 3 equals 2 over x minus 1. So here you can set y equals 1 over x minus 1. Then this equation will simplify as 1 plus y plus 2/3 then equals 2 times y, right? Because y equals 1 over x minus 1. So got this equation. This equation, so first simplify both sides. So 1 plus 2/3, that's give us 5 over 2 plus y equals 2y. So then both sides minus y. So we got a 5 over 2 equals y, right? Then you plug this one back. Y equals 5 over 2. Then what is x minus 1? Then here, you can just do the cross multiplication, right? Let me write that one to this side. You say both sides, you do the cross multiplication, this one times this one times this. You get 5 times x minus 1. This one equals 1 times 2, that's equals 2. So then you expand this one, you got 5x minus 5 equals 2. Then both sides plus 5, got 5x equals 7. So that means x equals 7 over 5, right? By this way, we get the solution for this problem. You can go back, check. If x equals 7 over 5, this one will be 7 over 5 divided by 7 over 5 minus 1, that's 2 over 5 divided by this. Then plus 2/3. This one, if this true, should equals 2 divided by 2 over 5. Now let's simplify this. This is a fraction divided by another fraction. We need to convert this one to multiplication. That will be multiplying the reciprocal of this fraction. That will be times 5 over 2, right? Then plus 2/3. So this 5 cancels out with this 5. So left side, that will equal 7 over 2 plus 2 over 3. Then we can simplify this one, will be common denominator, that's 6. Then this one will be 21 plus 4. This is 25, right? 25 over 6. Now let's see the right side. That will be 2 times, that's also division. 2 times 5 over 2. So this one got a 5. So that means somewhere we made a mistake. Say this check is so important. Now let's go back. If we set this one as y, let's say we'll get 1 plus y plus 2/3 equals 2y. Then this one, oh, say we write here, that's wrong. 2/3 plus 1, this one that's not equals 5 over 2, that's equals 5 over 3. Then plus y equals 2y. So that means y equals 5 over 3. Then that will be 5 over 3. Then we do cross multiplication. So now let's see, that means what do we write here that's wrong. So you can say check, it's very important. Sometimes you suppose you did it right, actually you did it wrong. So then we can get 3 equals 5 times x minus 1. So then we expand both sides. Actually, you can also do both sides divided by 5. You get a 3 over 5 equals x minus 1. Then both sides plus 1, you get x equals 8 over 5. Right? got 8 over 5. Now let's plug this one back, check. The denominator, that's this one will be 8 over 5. The numerator, denominator, that will be 8 over 5 minus 1. That will be 3 over 5. Then plus 2/3. This one will equals 2 over 3 over 5. Now let's say left side, 8 over 5. 8 over 5. 8 over 5 divided by 3 over 5. That means you need times, convert this one to multiplication, times 5 over 3. So this 5 cancels out with this 5. Now we got the 8 over 3, then plus 2 over 3. So then there'll be 10 over 3, right? So left side equals 10 over 3. This is left side. Now let's see right side. Right side is 2 divided by 3 over 5. So that means times 5 over 3. So then you got 2 times 5, that's 10. 10 over 3. Okay, say left side equals right side. So that means we did right. Correct answer, that's 8 over 5. Okay, say this is a process to solve this problem. Also I emphasize you should check. Otherwise, probably you make a mistake. Okay, then we finish this section. Now, actually, we already finished this chapter. Then let's go to the summary. In this chapter, we learned that one variable linear equation only has one variable in your equation. You can see here, you only has t in your equation, right? Sometimes you only have, usually we use x. And also the exponents of your variable default, that's 1. That's makes this equation as a linear equation. Otherwise, your equation will not a linear equation. Then we learn to solve the equations, linear equations in discourse. Then later we also has example. Remember that one? Root r. Later we got this one equals -2. Then that means this one has no solution. But if you just square both sides, you get r equals 4. This one we call this solution is extraneous solution. That means this actually is not a real solution. It's a fake solution. You can see this example here. Suppose they give you 3 root x minus 2 equals 30 minus root x. To solve this one, we can do substitution, set y equals root x. So this equation will convert to 3 times y minus 2 equals 30 minus y. So both sides plus y, we get a 4y minus 2 equals 30, right? So then now both sides plus 2, we get a 4y equals 32. Then we got a y equals 8, right? When y equals 8, then you can, from here, you can get x equals 64. Now let's plug back. So when x equals 64, this will be 3 times 8, this is 24, minus 2. This one equals 30 minus 8. Both sides equal 32. That's right, right? Now let's see what is happening. They call this one the extraneous solution. The equations in which a variable appears inside a radical are often solved by raise the equation to the approximate power. However, when we do so, we must be careful. Okay? So then remember that one, root r equals -2. For this one, you should not square both sides, otherwise you get the wrong answer. You must be careful, for sometimes the resulting equation has a solution that does not satisfy the original equation. We call this a solution an extraneous solution. For our example in the text, the r equals 4, that will be an extraneous solution. That's not a real solution. Okay? When you do this kind of operation, you need to be careful. Now, actually, we finished this section. Now, let's pick some exercise problems. Let's do some problems here. Let's find a difficult one. Okay, say all these problems, they don't have star. Let's go to challenge problems. Let's see what do we have here. Let's try to solve this first one. This one, they give us ask you to find r. If 3r squared plus r equals 27 plus 3r minus 2r. Say this is not a linear equation because the exponents of this variable is not 1, it's 2. Actually, this kind of equation later we'll learn called quadratic equation. That means quadratic means twice. So then now let's see how we can solve this equation here. To solve this equation, both sides simplify first. So left side you cannot simplify. You just write 3r squared plus r, then equals 27 plus r. 3r minus 2r, that's r. Then both sides has r. You can cancel out this r. You get r. 3r squared equals 27. Then both sides divided by 3. You get r squared equals 9. Then that means r equals plus minus 3. Right? R is positive 3, that's okay. R also can be negative 3. Then you can go back check. If r equals plus minus 3, then 3r squared that's equals 27. Then if r is positive, then plus 3, then equals 27 plus r plus 3. If for negative 3, that will here be minus. So that means this equation you have two solutions. One is r equals positive 3. Another is r equals negative 3. Right? Okay, say this is one problem. Now let's see. Okay, now let's solve 3.42. Let's see this problem. Everybody, you can try on your scratch paper, see how to solve this equation. Definitely, this equation is not linear equation, right? Because this on the variable on the denominator position. You know, that's if you write 2 power, that power is -1. So to solve this one, now let's see what we can do. There's a lot of ways to solve this one. Definitely do the variable substitution. That's one way. That's a general way we can use. To use that way, you can do this. You said x equals 1 over t minus 2. Set x equals this. Or set y equals it, does not matter. Then this one will be 3 times x And this one, you can just then write minus 9 over t minus 2. So that's minus 9 times x. Then this one equals 12, right? Because t minus 2, that's equals negative, you can take negative out here, then change this denominator, that will be t minus 2. So then that's the reason I put negative here. Then this one will be 9x. Then 3x minus 9x, you get negative 6x. This one equals 12. So both sides divided by negative 6, you get the x equals negative 2. Okay? After you got the x equals negative 2, then you plug to the substitution equation, you get this. This one, you can just flip this. You can also do the both side times x minus t minus 2. Okay? You can also flip. You got t minus 2 will equals negative 1/2. Because when you flip, you can consider this one as a fraction, right? Say 1 over t minus 2 equals negative 2 over 1. When you flip, you got a t, left side will be t minus 2, right side will be negative 1/2. So then both sides plus 2. Then you get this one, 2 minus 1/2. So this one will be 3 over 2. So this one will be the answer, right? Then you need to go back, check if this one correct. Go plug to the original equation. Say use 3 over 2, replace t. That will be 3 over 2 minus 2. Here you got a negative 1/2. Then 2 minus t. Then you got positive 1/2. Then 3 divided by negative 1/2, you get a negative 6. Then 9 divided by positive 1/2, you get a 18. So 18 minus 6, you get a 12. So this both sides are equal, right? So that means the answer, what we get, that's correct. Now let's find a very difficult one to solve. Okay, you can say, let's say this one. This one